Hi everyone, today we are going to study the classification of systems. That is, what are the different types of systems that can be studied in system analysis and design. Systems may be classified as formal or informal system, physical or abstract system, open or closed system, manual or automated systems. So basically we have four different types of systems. They can be formal or informal systems, they can be physical or abstract systems, they can be open or closed systems, and they can be manual or automated system. In general, four different categories of systems. Now let's study them in detail. A formal system. So first classification is that of a formal or informal system. So when we study a formal system, what is a formal system? A formal system is one that is planned in advance and is used according to a schedule. So any such system which is planned well in advance and there is a schedule for that system, and to run that system a schedule is followed, such kind of a system is called a formal system. In such a formal system, policies and procedures are documented well in advance. Whatever would be the policies of the organization, whatever procedures would be followed for that organization, all those things are documented in advance in a formal system. If I consider a real life example of a formal system, if you want to see a real life example of a formal system, it is to conduct a scheduled meeting at the end of every month, in which agenda of the meeting has already been defined well in advance. Like in many organizations, at the end of the month, a meeting is conducted and the agenda of the meeting is already decided in advance. It's not that when the meeting will take place, then you will decide what all has to be discussed. All the points that have to be discussed will be decided well in advance. That means the agenda or the purpose of the meeting would be decided in advance as to why we are gathering here together to discuss what, right? Say for example, the agenda of the meeting may be to find the profit of the organization at the end of the month, to find the number of sales done at the end of the month. So that means the agenda is decided well in advance. You know why you are meeting today in this particular room. So such kind of a system is an example of a formal system. This is an example of a formal system. Now the opposite of formal system is an informal system. It is formal system versus or informal system. So formal system we have studied. Now an informal system is the system that is not described by procedures. Just the opposite of a formal system. Whereas a formal system is described by procedures which are documented in advance, an informal system is not described by any such procedures. It is not used. An informal system is not used or very rarely used. It works on requirement basis. That means whenever and whatever the requirements are, that according to that the system will work. There will be no predefined policies or procedures for the system, as and when on requirement basis. If you want to consider an example of an informal system, sales order processing system through telephone calls. Like I can give you an example of cloud kitchen these days. These days there are cloud kitchens, people running food business from their homes and do not prepare order in advance. They prepare order as and when the demand for the order comes. You place an order online, they start preparing your order and then they deliver it. So as and when the requirement is, they will fulfill that requirement. So such an example is a kind of an informal system. The other category is your physical system or abstract system. That means either a system can be a physical system or a system can be an abstract system. Now, physical systems are tangible entities that may be static or dynamic. What are tangible entities? Any such entity that can be touched, that is in its physical form that can be touched is called a tangible entity, right? So physical systems are your tangible entities, and such tangible entities can be static or dynamic. Static is one that never changes, and dynamic is that changes according to the outside environment. So example of physical systems are computer systems, vehicles, buildings. These are all examples of your physical systems. So any such systems which are tangible entities are called your physical systems. They can be static or dynamic. Abstract systems, whereas, are conceptual entities. They are not tangible entities. That means you cannot touch them. They do not exist in physicality. So they are something conceptual. They are conceptual, hence they are called conceptual entities. Next is your open system versus closed system. Open system or closed systems. So open systems is a system within its environment. A system which exists within its environment and receives input from the environment and provides output to the environment. Any such system which is existing in the environment, in its own environment, it is receiving input from the environment in which it exists and it is providing output to the environment in which it is existing, is an open system. If you want to take an example of open system, any real life system, information system, organization, they are all examples of your open system. When I say any real life system, that means any real life system, be it an institute or a manufacturing plant or a restaurant. So all such real life systems or information systems also come under that category. Any organization, as I said, are all examples of open systems. So basically we can conclude that all these systems in general are open systems. Closed systems. Closed systems are isolated from the environmental influences, just opposite to the open system. Whereas an open system exists in the environment and interacts with the environment, a closed system is completely isolated from the environmental influences. It operates on factors within the system itself. It is also defined as a system that includes a feedback loop, a control element, and a feedback performance standard. So basically it has got nothing to do with the environment in which it exists. It is completely isolated from the environment. This kind of a system has a feedback loop, a control element, and a feedback performance standard. So if we consider this diagram will explain the closed system in detail. As I said that every closed system has a feedback loop, has a control element, and a feedback performance standard. That all we can see in this diagram. This is a diagram depicting the closed loop system. Now if you look at the figure above, if you look at the diagram above, it shows a closed loop system. Performance standard is defined as an objective that system has to meet. So there is a certain performance standard that is defined in advance, and you have to meet those standards because that is the objective. That is the objective that has to be met, that this should be the performance standard of the organization. So performance standard is basically used to meet the objective, or performance standard is set to meet a particular objective for the organization that the system has to meet. Then there is a feedback loop. A feedback loop is defined as a portion of the system that enables the system to regulate itself. See, just like you have feedback in every organization wherein on a quarterly basis or on a yearly basis, you get to know the performance of the system. How would you identify whether the system is working properly or not? You need to have some feedback system, right? So with the help of the feedback system, you're able to figure out whether you're going in the right direction or you need to make some improvements. Like if you consider institutes where you study, you must be having feedback forms every 3 months or 6 months or once in a year, where you give the feedback for your respective class teachers. How much would you rate the way they teach you? How much would they rate the way they assist you or guide you? So all such things. That means you're giving the feedback so that the institute can know how much the students are benefiting from the organization. So similarly, a feedback loop is defined here in a closed system, and it enables the system to regulate itself. You can regulate yourself properly with the help of feedback system. That helps you to identify whether you are going in the right direction or not. Then signals are obtained from the system describing the system status and are transmitted to the control mechanism. Whatever is the system status, that is obtained with the help of signals. That is obtained from this with the help of signals which are obtained from the system. So these signals obtained from the system basically do what? They describe the status of this system, and then they are transmitted to the control mechanism. So a control mechanism consists of a control element that compares the output with the performance standard. The control element is basically the controlling factor, which is doing what? Which is comparing the output with the performance standard. See, this is your performance standard that you have set. Now after at a certain stage you get the output, and this output has then to be compared with the performance standard, whether this output is matching this performance standard or not. If yes, you have achieved your objective. If no, you have not achieved your objective, right? So this control element is basically comparing the output with the performance standard, and then it adjusts the system input accordingly. If the output matches the performance standards, then no changes to the input have to be done. But if the output does not match the performance standard, then definitely the input has to be adjusted accordingly so that you get the output that matches the performance standard. Say for example, you run a restaurant. Now how do you figure out whether the customers are satisfied with your restaurant or not? You have some feedback mechanism wherein they rate your food, the quality of the food, the hygiene of the food, the taste of the food. So you have a feedback form. The customers give you feedback, and that feedback lets you know. So the feedback is basically working as a measure to identify whether you are meeting the performance standards or not. If the feedback is good, that means the output, that is the food that is being delivered, is matching the performance standards. So that means the input that you were putting, whether be it the ingredients, be it the way the food is cooked, all that input would remain the same if this output is matching the performance standard. But say if the customers are not satisfied with the hygiene of the food or the taste of the food, then that means the output, that is the food that is being delivered, needs to have some changes. And how those changes will be done? By changing the input. That means you can use better quality of ingredients, better quality of oils. You can cook them properly, or you can prepare them in a much better way which you were doing earlier. So the input has to be adjusted to get an output which meets the performance standards. So by adjusting the input, system input, you can achieve an output that matches the performance standards. So this is how a closed system works. The last category of the system is your manual and automated system. A system can either be manual or it can be an automated system. The system which does not require human intervention is called automated system. Any such system in which human intervention is not required, a human being is not required to do anything, is called a automated system. So because in this system whole process is automatic. For example, traffic control system. The traffic control system that you have in your city is an automated system, right? It is not being operated by somebody that in every 10 minutes or every 8 minutes the lights will be changed. Nobody is changing those lights for you. That is happening automatically. So there is completely no human intervention in that. So a traffic control system is the best example of an automated system. You can think of several such other systems also. Next is your manual system. So if an automated system is one such system that does not require human intervention, then a manual system is complete opposite of that. The name itself says manual, right? So that means any such system which requires human intervention is called a manual system. If you consider the example of a manual system, it would be a face-to-face information center at places like railway station. You go at a railway station, and when there is a face-to-face interaction with the people sitting at the reception or the counter, it is a complete manual system. At each and every phase, human intervention is required there. So that is an example of your manual system. So these are the different kind of systems that you can have in system analysis and design. Now next, other than systems, we also have subsystems in SAD or system analysis and design. So when we study SAD, basically we study systems and then we study subsystems also, because subsystem is basically nothing but a part of a system. So what is a subsystem? When you study system, you need to study subsystem also, because subsystems are a component of a system. A subsystem is a component of a system even though it can be considered as a system in its own right. For example, consider a manufacturing firm. It consists of 5 subsystems, namely product design, production sales, delivery, and service. So if I consider a manufacturing firm is a system in itself. Now this system on its whole cannot work without dividing it into various components. You divide this system into various subsystems. So you have basically several modules, and each module then does its own independent task, so that things become less complex. You know which department is responsible for which particular work, right? You know which department is accountable for which particular work. Things become easier for the people, things become less complex, things become organized. So when you bifurcate or you divide the system into various subsystems, or when you divide the system into various modules, those modules or subsystems, those modules or those components are known as the subsystem. Like a manufacturing firm has one module called the product design. So this would be considered, when the manufacturing firm is the whole system in itself, the product design would be considered as a subsystem of the manufacturing firm. Another component, production, is again a subsystem of the manufacturing firm. Sales is a subsystem of the manufacturing firm. Delivery is a subsystem of the manufacturing firm, and service is also a subsystem of the manufacturing firm. Now all these subsystems work independently, yet they are interdependent upon each other. They are correlated with each other, and together they help this entire system to achieve its goal. And then if you look at them individually, they can be considered as a system in its own right while it is doing its own independent function. For example, in a manufacturing firm, you need to first of all design the product before you actually start producing it or manufacturing it. You need to have a blueprint, or you need to have a picture of that product on paper as to how you will produce it, right? So the product design in itself is one department or one subsystem of the manufacturing firm. Then production, okay, once the product has been designed, now the actual production work starts. You will start manufacturing. So the production is again another subsystem of the manufacturing firm. Sales once the production has been done, you need to sell it? No, because you've not produced it to keep in the company. So once the production has been done, you need a separate dedicated team to do the sales job so that that product is sold. So this is one component of the this is one subsystem of the manufacturing firm. Then once the sales has been taken care of, the delivery, how the product will be delivered, and once the product has been delivered, after delivery services provided to the customer. So these are all subsystems of this main system manufacturing firm. So in this system, all the subsystems work together to achieve a goal.